Hello, my name is Roy Zagami, and I'm a technical marketing engineer with Cisco's Server Access Virtualization Group. This video is part of a series that is intended to show some of the unique advantages made possible by Cisco's server offering, called the Unified Computing System, or UCS for short. This video will show the viewer the details of the new UCS group power capping feature. Some of the major group capping features are that it comes at no additional cost to the end user. It's fundamentally built on the concept of power groups to simplify group cap management. One major issue in the lack of use of power capping in the industry has to do with managing those power caps. If caps are forced to be set at the server level, and you have thousands of servers in your data center, that creates thousands of extra management points. It's fully integrated with the concept of service profiles. We allow the end user to assign priority values to the various service profiles, and the capping software will use that priority to preferentially grant power and therefore performance to high priority workloads if there is contention. UCS group capping caps at breaker speed to fully protect power circuits in the data center. This video assumes that the end user is familiar with some of the basic concepts of the UCS system. Specifically, we will talk about policies and service profiles. Step one of setting up group capping is to set the global power allocation policy. We'll do that now. There's two choices here. We can do manual blade level power capping or policy-driven group capping. Group level power capping, power caps are set for groups of enclosures, and individual power allocations are distributed to the blades based on overall demand, power allocation, and service profile priority. Obviously, if group caps are set, you would not want end users to accidentally explicitly set the power cap for an individual blade. That's why we have the global power allocation policy. It allows users to make a global selection regarding whether they want to use group capping or individual blade capping. For the purpose of this demo, we want to make sure that we have policy-driven group cap selected. The next thing we want to do is take a look at the service profiles on the system to understand how capping works with UCS service profiles. If we select one of our service profiles, take a look at the Policies tab, and select the Power Control Policy configuration, we'll see something called the Power Control Policy. Power Control Policy defines the priority of the workload associated with this service profile. If power group runs out of power, those profiles that we designated as important will get a higher share of the available power and therefore more performance. Right now, the default policy is selected. Let's take a look at the default policy. The default policy sets a priority of 5 for the workload. Priority values can vary from a scale from 1 to 10, with 1 being the highest priority. So the default is right in the middle in terms of level of importance or priority. Let's assign our own power control policy. The easiest way to create a new power control policy is to click the Create Power Control Policy right here in the window. Let's try My Policy. So once we give it a name, we have to assign a priority level to the policy. Again, power policies can have a value of 1 to 10 for their priority, or you can even designate a service profile as uncappable. Uncappable service profiles are just that. UCS won't do anything to cap power on blades with that designation. As we'll see later, the system assigns a fixed power allocation to a power group. Uncappable blades must be assumed to consume the worst case power and have the largest power allocation assigned to them. Using uncappable blades in a power group may cause blades with cappable service profiles to be capped before the overall power group allocation is consumed. Consider using priority 1 service profiles in place of uncappable service profiles. So let's do that. We're going to assign a priority of 1. And now we're going to assign my policy to the service profile. So select my policy in the drop-down box, and don't forget to click Save Changes. Okay. So the next step is to create a power group. We go back to the Equipment tab and select Power Groups. You take a look at what's already set up on the system. First, we can see from the Power Groups tab here that this UCSM instance is managing 2 UCS chassis. Since there are no user-created power groups, both chassis are part of the default power group, which isn't capped. To create a new power group, we right-click on the top of the tree, say Create Power Group. Call it Roy's Group. Click Next. And here we can add one or more chassis to the power group. In this example, I'm just going to add chassis 1. We could just as easily have added chassis 1 and chassis 2. Click Next, and now we're going to assign a power cap value to this power group. I'm going to pick 4992 for the AC power cap. Now, why such a specific number? A standard 30 amp 208 volt single phase power circuit can deliver a continuous power of 4992 watts. So we're going to set that for the power limit. We could just as easily have added the second chassis, and our power allocation would have applied to both chassis. So I'm going to click Finish here. Say OK. Now if we go back to our power groups, we'll see that the default group now only has chassis 2. Chassis 1 is no longer part of the default uncapped group. And Roy's group, which I just created, has chassis 1. We can expand this tab and see the the blade level power allocations associated with this chassis. And that's it. It's really as simple as that to create power groups and assign an overall power cap value within UCS. This ends this UCS Advantage video, where we show how unique capabilities in the Cisco UCS can lead to simplified deployment models with much faster service turnaround to meet the increased demands of the business. Please go to www.cisco.com/go/UCS for printed collateral, including a brochure that highlights the information shown in this video. Thank you very much.